Yeah, so I'll post these next year so people can watch them. I mean, I'm going to do all this with them next year, but they can already watch the video if they want. All my subscribers. Okay, so the first one, harsh. The first one, all right? You should notice this integral has one of our properties. What do you notice is happening in this first one? A constant. Thank you, Julia. It has a constant, this 4, which I'm going to rewrite this to move that 4 to the front of the integral. So I'm going to do 4 times. The 4 is going to multiply by whatever this value for that integral becomes. So that's basically like 4 times the area under the curve. Exactly. So we have f of x dx. One note of caution I would always make sure you guys do when you're doing these is to make sure that your limits of integration are going from least to greatest. Are my limits of integration going from least to greatest? Yes, -6 to 3. So just be aware of that. All right, so let's start here. -6 to -3, I see an 11. So I'm going to put a positive 11. All right, but what do you notice about this area under the curve between -3 and -1? It's below the x-axis. So today, if you see an area value that's below the x-axis, you can either write plus a negative or put minus that number. So if you want to put adding a -3 or subtracting 3, whatever you want, it's your choice. Okay? Not done yet. All right, our last one from -1 to +3 has a 13, and that 13 is above the x-axis. So I'm going to put plus 13. So whatever this is, then I'll multiply it by 4. All right, so what is 11 minus 3? 8. What's 8 plus 13? 21. And what is 4 times 21? 84. So this integral is equal to a value of 84.
Wait, so you said that this could be plus or minus?
Well, so what I was saying is you could either write it as I wrote it, as 11 minus, or you could write it as, some students might write 11 plus -3.
Oh.
No. It has to be subtraction. What I'm saying is some students might say, hey, I'm still adding everything, but because it was below the x-axis, I want to make sure I know it's a negative. That's fine. Good question. I'm glad you asked. Any questions on the first one? All right, let's go to number 2. Georgie. Okay, you good? All right, so here we go. Number 2 says find all x-intercepts b for which the integral from -8 to our value b, so we're going to pick some numbers for b, that would make this integral become 0. So I was trying to use the very first one that I talked about with you guys before we did this. Whenever you see 0, the easiest one to do is to make this letter b what? The same value as the other limit of integration. So one of my answers will be -8. Because if I make the integral from -8 to -8, that value will be 0.
Why do you say 1?
Well, there could be others, right? All I know right now is that one definitely works. But now I'm going to look at my values here, right, David? Because maybe I can make this letter be a different number so that when I adding negatives, subtracting, it'll make 0. So my first thought was, here's -8. What's the value from -8 to -5? 8, but it's below the x-axis. So if I go to -2, right, I see this 8 is above the x-axis. What is -8 plus 8? 0. So if I also use -2, right, the integral from -8 to -2 of this function is also 0. Now, always check to see if there's another one. This is it. There's only 2 answers here. But is there a way I can make this 3, which is below, so like a -3, a -14, and a +8? Could I make any of that become 0? Right, so these are done. Can I make these other 3 become 0? How, Georgie?
Like move it a little bit to like an 8 somewhere. Like where 8 is, just like a little bit.
Are you talking about this 8 or are you talking about that 8?
The 8, the first one.
This one?
Yeah, just like a little bit of that area.
Yeah, you can't take a little bit of the area, though. You got to take all of it.
You can like, so like
I mean, like, I know technically you could, but in terms of answering this question, that's it.
Couldn't you do it from negative 5?
Are you trying to skip?
Yeah, I was gonna say.
Can't skip. Can't jump it, right? Because the idea is if you do -8 to 3, right? So you're trying to get this +8 to make that 0, but you've got this, which would end up being a +5.
I was gonna say from -5 plus integral.
You can only use one letter. That's it. That's all you can do. You can't add an integral. Good question, though. Yes, you could do -8 to -5 of your function plus the integral from 0 to 3, and that would also be 0. But in this case, it's just one integral. Good question, Dave. All right, let's go to number 3. Anyway, so what you would type in is you would type in those two numbers. All right, let's go to negative. Let's go to 3. Okay, notice there's no constants. It doesn't say the function's going to, or excuse the integral value will be 0. All right, but take a look at the limits of integration. Is it going from least to greatest? No, right? This really should say -8 to -1. So I'm going to take a moment and write this as the integral from -8 to -1 of my function. But if I do that, what do I have to put in front of this new integral? The negative symbol. And remember, it doesn't mean that the answer will necessarily be negative. It means your answer will be the opposite, whatever you get. So just kind of ignore this negative sign until the very end and then make it the opposite symbol. Okay? So let's do -8 to -1. What is the first area value from -8 to -5? -4, right? Because it is below the x-axis. What's my next one? +9, right? Because it is above. And that's going from -8 to -1. So that's done. All right. So what is -4 plus 9? 5. But remember, is this the answer? No, because I need to bring down that negative to do the opposite of all that. So the opposite of 5 is -5. And this is the answer, yes. So just wait till the very end and then make it the opposite. Now, I know this one became a negative, but it doesn't always work that way. Okay. It could be, yes, right? Like if this had been 9 and this had been 4, then you would have had -5 to start. The opposite of that would be +5. Everybody good on number 3? Trying to do as many of these different properties as I can. Again, as I mentioned, there's like 3 other types of problems that I did not put on here. But if you are having trouble with them while you're practicing, I'll come by and help. Let's do one more. It's the last one. I think this is the hardest one. All right, here we go. Number 4. All right. This says the integral from -8 to 5. So notice -8 is less than 5, so I'm good there. Don't need to change anything. But then it doesn't just have a function. It doesn't just have a constant. It has, in parentheses, -3. So what I want you to do is rewrite this as 2 integrals. So the first one is -8 to 5 of your function. And then one of our properties I stated was if you have 2 things in your parentheses, you can subtract, or Angel, if you wanted to write plus the opposite, I don't care. Subtract the same integral, but here's where I'm going to put 3 dx. So do you see how I split it into 2 integrals? Now, if this would have said f of x plus 3 in parentheses, I would have used addition. All right, so just make sure you have the correct symbol there. You could have also written addition, but then this would need to be a -3 in that integral. Okay, your choice. Everybody okay? All right, let's do the first one. I think we'll have hopefully minimal issues with this first one. So I'm going -8 to 5. So my first area I see is -8 to -5. That 4 is where? Below, so I'm going to put -4. Plus, my next area from -5 to -3 is 7, and that's above the x-axis. All right. Then my next one is -11. And then my last one from 0 all the way to 5 is -19. So let's go ahead and find that. What's negative 4 plus 7 plus negative 11 plus negative 19? Negative 27. How'd you do that? How'd you get that? He did not use a calculator. I'm looking at him. Well, which numbers did you go left or right? Okay. Did anyone else do it differently? You did right to left? I did negative 19, negative 11, because that becomes negative 30. And then I was like, all right, well, it doesn't matter at this point. So I did negative 34. Then 34 minus 7 gives you 27. All right? Pretty good? Okay, now that's not the answer, because we still need to subtract this over here. Now I'm going to do a little drawing for you. And you can draw this or not, or just watch. All right, just a quick little drawing. Again, doesn't need to be very large. All right, so I'm looking at negative 8 to positive 5, right? Those are my limits of integration. I'm focusing on this second integral. All right, do you see this 3? Right? Do you see how there's no x associated with it? Right, it just says 3. Do you remember when you guys were in algebra, what this looks like when you graph y equals 3? There you go. I want that word. It is a horizontal line. You did it. All right. It's a horizontal line at y equals 3. So it'd be like this. Right. If this is y equals 3. Could you find the area under the curve if I drew that? How would you find that area? Right? Because what shape did I just make? A rectangle. So I think these are the toughest, because you're going to have to find this area under the curve by making a rectangle. All right, so this distance, if I went from negative 8 to 5, is going to be 13. All right, so negative 8 to 5 is 13. And then what is my height, or you could say your width, is 3. So what is the area of that one? 39. Now be careful here, right? I'm putting 39 there because that is my area, but notice what operation is happening before it. I'm subtracting, so it's minus 39. So negative 27 minus 39 is going to be a negative number still. What is negative 27 minus 39? Negative 66. And that's how you do number 4. So I'll walk by and help if you're having any issues with this type of this type of question. I think these are tough. Make sure when you get to do this second piece that I would recommend doing the sketch. All right, you're in line to go. Mauricio is going to start.